Chapter 11 is cost behavior and cost volume profit analysis. So cost behavior. So this is the manner in which a cost changes as a related activity changes. So variable, fixed, or mixed. So as you manufacture 100 units, do your fixed cost change? Do your variable cost change? Mixed? So that's what we're going to take a look at, is how do costs change as activities change, as you manufacture more. So two things to consider. One is an activity base. So activities that caused a cost to change. So food service costs change with the number of hospital patients. So our total cost of food service might be $1,000 for 100 patients. But if we have 200 patients, our total food service cost changes because we have more patients to feed. So as we get more people, we have to buy more food. So that would be the example of an activity base. And then the relevant range is the changes in cost are of interest. So if we want to look at the food service costs and we're looking at the number of patients, so if the hospital can only hold 5,000 patients, we're not going to look at how much it costs to feed 150,000 patients because we can't get that many people in the hospital anyway. So it's not in the relevant range. The relevant range is the range of interest. So variable costs vary in proportion to changes in the activity level. So variable cost is we have more patients, therefore our cost of food goes up. So here's an example. So if we're manufacturing DS300 units, and our direct material cost per unit we manufacture is $10. So every DS300 we make, it costs us $10 in direct materials. So we manufacture 5,000 units, times $10, our direct materials cost is $50,000. If we manufacture 25,000 units, direct material cost is $10 a unit, therefore our total direct materials cost is $250,000. This is a variable cost. So as we produce more units, our cost increases. So the activity level would be the model DS300s produced. So as the model DS300s produced goes up, direct materials goes up, variable cost. So here's a graph of variable cost. So if we look at the x-axis, we have total units produced, and the y-axis is total direct materials cost. So you can see that as we produce more units, the total direct materials cost goes up, variable cost. But the cost per unit stays the same. So regardless of how many DS300s we produce, it's still $10 of materials per unit. Fixed costs remain the same regardless of how many units you produce. So if we look at Molly Hahn's salary, whether we produce 50,000 bottles or 300,000 bottles of perfume, we're still paying Molly Hahn $75,000. It's a fixed cost. But when we look at her salary per bottle of perfume produced, that actually goes down as we produce more units. So we're still paying her $75,000. We just spread it across more units of perfume produced. So if we look at our graph here, so our x-axis, total units produced, and our y-axis, total supervisory salary, you see no matter what, it's $75,000. So that's a straight line. If we look at the other graph, our salary per unit and our units produced, so you see as we produce more units, we spread that $75,000 over more units, so our cost per unit goes down. Remember, cost per unit is $75,000 divided by units produced. So as the denominator gets bigger, you see the graph goes down. So mixed costs have characteristics of both variable and fixed costs. So what happens is it's fixed over a certain range, and then it becomes variable depending on an activity. So you can see in this example, from 0 to 10,000 units, the rental cost is $15,000. As we start to produce units over 10,000 units, or 10,000 machine hours, as we get over 10,000 machine hours, then our rental cost becomes variable and goes up with machine hours. But for 0 to 10,000 machine hours, it's fixed at 15,000. Then after 10,000 machine hours, it becomes variable. A popular method to determine the average cost per unit is what's called the high-low method. So if we take our graph, so we have June through October, we have the total maintenance cost for during the 5 months, and then we have the units that we produced for each of those 5 months, June through October. So if we take production and total cost, we take the highest level of production, 21,000 units. We take the highest level of total cost, which is 61,500, and they don't necessarily have to always fall into the same month. You just take the highest one from each column. And then you take the lowest level from each column. Lowest production is 750, lowest total cost of 41,250. And then you would subtract the two, 21,100 minus 750, 61,500 minus 41,250, and you calculate the difference in the two. So then you would divide those. So you take the difference in the total cost divided by the difference in production, and you would come to $15 per unit. That's our variable cost per unit. So now if we want to calculate our fixed costs so we're taking our total costs, which we saw in the previous slide, and we want to break out our variable and fixed costs. We know our variable costs are $15 per unit. So our fixed cost would be total cost minus variable cost. So our fixed cost equals, we're just going to pick the 2100 unit level. So the 2100 unit level, our total cost was 61,500, and then we're going to subtract our variable cost, which is $15 per unit times 2100 units, and we calculate our fixed cost to be $30,000. And if we do it with the 750, the lowest level, we'll get the same $30,000. So we know that our fixed cost in the graph in the previous slide are $30,000. And then our variable cost, we would take the number of units times $15 per unit. So that's using the high-low method to break out fixed and variable costs.